We would like to estimate the arc length on a function from x value 3 to x value 7. We're going to do so using one line segment, even though we could have more accuracy if we used multiple line segments. But let's just enjoy the process. So we want to know now, what is y when x is 3? Let's plug it in. 3 cubed minus 2 times 3 squared minus 4 times 3. Take away 8. That's 27 minus 2 times 9 minus 4 times 3. Take away 8. 27. Take away 18. Take away 12. Take away 8. The difference is negative 11. Let's repeat this process for 7. When x is 7, we want to know what is y. That's 7 cubed minus 2 times the square of 7 minus 4 times 7. Take away 8. That's 343 minus 2 times 49, and so on. 343, take away 98, take away 28, take away 8 gives us a difference, 209. We now have our coordinates from the graph. That's 3 and negative 11, and 7 and 209. We want to find out how far it is from here to there. Now we're going to have a not so accurate approximation, since we're considering the distance between those points using a line as opposed to a curve. Let's just go for it. So the change in the x's, that's 7 take away 3. Order doesn't matter here since you're squaring. Change in the y's, 209 take away a negative 11. Okay, we'll square that. Well, that is the square of 4 and the square of a positive 220. That's going to be a whole lot. That gives us 16 and 48,400. We'll add those. Rats. 48,416. We'll take the square root and find that that distance is approximately 220 units, and then some. If we like, we could round that to the nearest hundredths place. Since we've got 5 or higher, let's go ahead and round it up. So we're saying that the distance along that arc is approximately 220 units with just one line segment. Of course, it would be more fun to have a line segment from x is 3 to 4, from x is 4 to 5, x is 5 to 6, and x is 6 to 7. But let's save time.